Hello everyone, my name is Elena Sofia. I am a student in SMA Negeri 4 Bandung, and today I will be assisting you guys in this topological journey. The objective of this research is to provide people who may not be familiar with topology a view into how the Mobius strip and the Klein bottle relate to each other using topology, and how to help the reader visualize the Klein bottle in the fourth dimensions. The goal of this research is to gain more acknowledgement on topological mathematics and to have a better understanding in these two non-orientable manifolds. So this is a brief introduction to topology, but I'd rather say that topology is such a beautiful branch of mathematics that consists of the study of shapes and objects. Okay, so let's start with the famous Mobius loop, or some of you may know it, the Mobius strip. But it's the same thing. It's a simple one-sided surface that can be easily made with a piece of paper by removing the end of the strip and then twisting it 180 degrees and combine them together, and you can make this famous object. The Mobius loop was originally proposed by an astronomer and a mathematician named Ferdinand Mobius. And now we go to the Klein bottle, which is my favorite. So the thing that makes me interested in this object is that the Klein bottle cannot be constructed correctly in a third-dimensional space. But you can still see the shape with an intersection in the third-dimensional world. As you can see, this is the part of the intersection over here. So in the fourth-dimensional world, it does not have to intersect with itself. Okay, so the first thing that I did for this research is to clarify the correlation, and then I imagining the fourth dimension, and then I applied the same logic so that I can project the object in the third-dimensional plane model using Grapher in macOS to prove the existence of the intersection. Yeah, so the first thing that I do for this research is to clarify the correlation. As you can already see that the Mobius loop and the Klein bottle is correlated. If two Mobius tapes are glued together along their edges, a surface is created that corresponds to a small bottle, like this. These are two Mobius loops, and if you put it together, if you glued all the edges, you will get a Klein bottle. Yeah, and then in this step is to imagining the fourth dimension. First, we will illustrate that the Klein bottle does not intersect with itself in the fourth dimensional world. But before doing so, we have to take a step back to dimensions that we can see. We can start by imagining two-dimensional space with the length and the width that has an intersection with itself. If we bring that shape into a three-dimensional world, we can easily lift one of the lines up to give the shape some height. And thus we can make it so that the shape does not intersect with itself, and that we can apply the same logic to the third dimensional world and the fourth dimensional world, which in this case is our problem. By these figures, we can see that when in three-dimensional world, the Klein bottle intersect with itself once. If the coordinates of the fourth dimensional world are the x, y, z, and the w, then in the third dimensional world, it would be x, y, z, and 0, with 0 height in the fourth dimension. To remove the intersection of the three-dimensional world, we need to increase the fourth coordinate, which is the w, to lift the Klein bottle so that it does not intersect with itself. So this is the projected Mobius loop that I created earlier. So as you can see, it connects. Basically, if I turn one off, as you can see, it's a Mobius loop. This equation basically is to perform a Mobius loop in a third dimensional world. And as you can see now, and if I overlap them together, the right and the left one, and you try to connect these edges, both edges, it will create this object called the Klein bottle, this one, it will look something like this. And I made the equation like this. And as you can see it now. It's basically this the shape that I made before. This one, the two Mobius loop combined together, and then I kind of like sew the edges together. These are the result, and as you can see, it is almost the same as the one that I showed you earlier. It's the same type of line bottle, and it has the same intersection, and the object over here kind of like proving the fact that it is two Mobius loops combined together. And then if you can see the blue part over here, that is the intersection that we don't want to see. So yeah, we have to see it because we live in a third dimensional world, but in the fourth dimensional world, it doesn't necessarily have to be existing. So now that we reached to the conclusion part, I wanted to tell you that the whole point of this research is for us to see that both the Mobius loop and the Klein bottle have interesting and useful geometrical and topological properties, and that the Klein bottle does not intersect itself in the fourth dimension. Although the Klein bottle consists of two connected Mobius loops, but their topological properties are not the same. Thank you so much for having me. Enjoy your day. And that's all from me. Thank you so much for having me. Enjoy your day.